Numbers. They are the building blocks of our universe, quantifying everything from the smallest atom to the vast expanse of space. Yet some numbers are so large that they defy easy comprehension. They are the giants of the numerical world, pushing the boundaries of our imagination and challenging our understanding of scale. These numbers, like distant stars, beckon us to explore their depths. They spark our curiosity and ignite our sense of wonder. Why are we so fascinated by these colossal figures? Perhaps it is because they represent the unknown, the edges of what we can grasp. Or maybe it's the sheer magnitude that captivates us. Whatever the reason, large numbers hold a unique allure, inviting us on a journey to the very limits of thought. Join us then as we venture into the realm of the incredibly large, where numbers stretch towards infinity and beyond. Our journey begins with numbers that, while large, are still within the realm of everyday experience. Millions and billions. A million, a one followed by 6 zeros, is a number we encounter often. It's the population of a large city, the price of a luxurious house, or the number of views on a viral video. A billion, 1,000 times larger than a million, is a number often used in finance and economics. It represents the wealth of nations, the value of companies, or the cost of large-scale projects. While we can grasp the concepts of millions and billions, they serve as stepping stones, leading us to numbers far more abstract and immense. To journey further into the realm of large numbers, we need to understand the concept of exponential growth. Imagine a single bacterium dividing into 2, then those 2 dividing into 4, and so on. This is exponential growth, where each step multiplies the previous number by a fixed factor. Exponential growth is how seemingly small numbers can quickly become astronomically large. It's the power behind compound interest, the rapid spread of information online, and the sheer vastness of the universe itself. With this understanding, we can begin to explore numbers that dwarf even the billion. Our next stop is the Googol, a number so large it was named after a child's invention. A googol is a 1 followed by 100 zeros, a figure far greater than the estimated number of atoms in the observable universe. To put it into perspective, imagine trying to write out a googol. Even if you could write 10 digits every second, it would take you longer than the age of the universe to complete the task. The googol, while vast, is merely a stepping stone on our journey. It pales in comparison to the next number on our list, the googolplex. Section 5, Googolplex, dizzying heights of numbers. If the googol made your head spin, brace yourself for the googolplex. A googolplex is a 1 followed by a googol zeros. It's a number so large that it's impossible to write out in its entirety, even if we used every atom in the universe as ink. To visualize a googolplex, imagine a library containing every possible book that could ever be written, with each book having a googol pages. The googolplex is far larger than the total number of pages in that impossible library. The googolplex represents a point where numbers become so large that they defy easy visualization or comparison. Yet, our journey continues, venturing into realms where even the googolplex seems insignificant. Section 6. Infinity, a concept, not a number. Before we delve into even larger numbers, it's important to address the concept of infinity. Infinity is not a number, but rather an idea, a concept that represents something boundless, endless, without limit. It's the opposite of finiteness, the state of having an end. In mathematics, infinity is used to describe concepts like infinite sets, infinite series, and the infinite extent of a line. While we can use infinity in calculations and equations, it's important to remember that it doesn't behave like a regular number. Infinity serves as a reminder that the realm of numbers extends far beyond what we can easily comprehend. The Section 7. Beyond imagination skews number. Our journey now takes us to the realm of numbers so large they defy even our wildest imagination. One such number is Skews' number, named after the mathematician Stanley Skews. This number arose from a problem in number theory, specifically the study of prime numbers. Skews' number is incredibly large, even compared to the googolplex. To express it, we need to use a notation called power towers, where we repeatedly raise a number to a power. Skews' number is a testament to the power of mathematics to explore concepts far beyond our everyday experience. Section 8, Graham's number reaching for the unreachable. Even larger than Skews' number is Graham's number, named after mathematician Ronald Graham. This number is so large that it's impossible to write down in any conventional notation, including power towers. To represent Graham's number, we need a special notation called Knuth's up arrow notation. Graham's number arose from a problem in Ramsey theory, a branch of mathematics that studies how order emerges in seemingly random structures. It's a number so large that even attempting to visualize it is futile. Graham's number represents a point where numbers become so vast that they challenge the very limits of human comprehension. Section 9, Tree 3, Scaling the Heights of Incomprehensibility. Our final stop on this journey takes us to Tree 3, a number so incredibly large that it dwarfs even Graham's number. Tree 3 is difficult to define succinctly, but it arises from a problem involving trees, mathematical structures used to represent hierarchical relationships. Tree 3 is so large that it makes Graham's number look like an infinitesimal speck. It's a number that pushes the boundaries of mathematical notation and challenges our very understanding of scale and magnitude. Tree 3 serves as a humbling reminder of the vastness of the mathematical universe and the limits of human comprehension. Section 10, Conclusion, The Infinite Wonder of Numbers. Our journey through the largest numbers has taken us from the familiar realm of millions and billions to the dizzying heights of Googleplex's, Skews' number, Graham's number, and beyond. We've encountered numbers so large that they defy easy visualization and challenge the limits of human comprehension. Yet these numbers serve as a testament to the power of mathematics to explore concepts far beyond our everyday experience. They remind us that the universe of numbers is vast, infinite, and full of wonder. As we conclude our journey, let us carry with us a sense of awe and curiosity for the boundless world of numbers. For in the realm of mathematics, there is always more to discover, always further to explore, and always larger numbers waiting to be imagined.